Geometry, Chapter 2, Section 3, Mathematical Modeling. The idea of mathematical modeling is we take a real-world problem and we convert it into a math problem. So let's look at what we have here and let's see what I can convert this into a math problem. A biology experiment shows a growth of a bacteria. Each cell grows an additional 4 cells if there is room each hour. A cell can only grow out in the northwest, southeast directions. So here we've got hour 1, hour 1, hour 2, hour 3. So from hour 1, you got a single dot. Hour 2, you can see it grew out in the north, south, east, and west directions. Hour 3, the original one, can't grow because there's already dots in those directions. But then you have this dot grows. This dot, can only grow in these directions. This dot can grow. And so it's constantly expanding out. So let's first see if we can determine what hour 4 will look like. So I'm going to start expanding it out. This dot, he can expand here, here, here. This dot, he can expand here, here, here. So you can see expanding out. Now, currently none of those dots could expand out because all the spaces that they could expand to are already taken. So let's count up how many dots we have in each of these. We have 1 dot, 5 dots. We have, looks like we have 13 dots. We've got 9 right here, plus 4. Now let's look at this one. So it looks a little bit more complicated. We've got our 13, and then I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 additional dots. So we've got 25 dots. Now we could take this to hour 5, hour 6, and so forth. But let's see if we actually can create a mathematical equation for it to determine how many dots will there be by hour 20 or hour 50. So there we go. We've got this converted. Let's see if we can create an algebraic expression for this. Let's see if we can follow the same sort of logic we were using previously. Well, let's see. This increases by 4, 5 to 13. That's increasing by 8, 13 to 25. That's increasing by 12. So maybe we can use the same logic and say, look, goes by 8, by 4, by 8, by 12. Maybe the next one goes up by 16, and so forth. Let's see what else we also can come up with, because our equation is going to look a little bit different than it did in the previous section. Let's think about things in terms of increasing exponentially. So I'm going to put this in some thoughts of some squares. 1 squared. Oh, okay. 1 squared is 1. Okay, that works. 2 squared is 4. So 4 plus 1 gives me 5. 3 squared, well, that's 9. 9 plus 4 gives me 13. Okay. 4 squared gives me 16. 16 plus 9 gives me 25. Well, 1, that's 1 squared. 4, that's 2 squared. 3, that's 3 squared. So we have an interesting pattern here that can be written as the equation n squared plus n minus 1 squared. So let's double check that. Does that actually work? Let's try it for term 4. 4 squared plus 4 minus 1 squared. 16 plus 9, 25. It does work. And so that is our algebraic equation for our biology problem. Let's do a little bit of algebra review. So here we got our equation. We got to solve for x. So we got to remember some of the things that we can do here. Well, this is 2 times this whole expression. So I'm going to distribute that 2. So I get 2x plus 8. Oh, we got another distribution over here. So that's a negative 3 I'm going to distribute here and here. So negative 3 times 2x is negative 6x. Negative 3 times negative 6 is a positive 18. So now let's combine like terms. 2x, negative 6x, that's negative 4x. 8 and 18, and so we get plus 26. Subtract 26 from both sides. Divide by negative 4. And we get x equals 1. Now, if you want to confirm that you did this right, plug it back in. 2 times 1 plus 4 minus 3. 2 times 1 minus 6. So that's 2 times 5, which is 10. Minus 3 times, that's 2 minus 6, negative 4. So that's plus 12. 10 plus 12 is 22. We did it right. They match. Let's do one more. Okay, so we have the same idea. It's 5 times this whole expression, so distribute. So that's 5 times negative 2x, so negative 10x. 5 times negative 2, negative 10. Plus 7 equals distribution here again. Negative 3 times 4x, negative 12x. Negative 3 times 2, negative 6. All that minus 12. Let's combine some like terms. So negative 10x. Negative 10 plus 7 is negative 3. Negative 6 minus 12 is negative 18. I'm going to add the 12x to this side. I'm also going to add 3 to this side. So I get up with 2x equals negative 15. Divide by 2. X equals negative 7.5. And if you want to confirm that you did it right, plug it back into the equation, see if it works out. And that is the end of this lesson.